Okay, so this is the SKE 3223 microprocessors class for section 1, 2, and 3. Okay, my name is Dr. Muhammad Afzal Ahmad. Okay, my room is at P08219. Okay, so this is the extension, okay, for my room. Okay, and then the email is afzal@fke.utm.mat. Okay, so before we start with our Module 1, okay, so let's look at the introduction of this SKE 3223. Okay, so this is the aim of this subject. Okay, so this subject will introduce the principle and the usage of microprocessors. So in this subject here, you will learn about microprocessor. Okay, so the microprocessor that we're going to use in this class is called Atmega 32. It is one of the AVR ICs. Okay, so a few topics that are emphasized on this subject are such as a processor architecture. Okay, you will learn about the architecture of the processor that you're going to use. Okay, how many input output port, and then how many the pin out. Okay, what the processor looks like, and then at the same time, okay, you're going to do programming. Okay, so in this class here, we will going to use two language. Okay, one is a assembly language, the other one is C language. And then after that, at the end of the class, you will learn about basic interfacing, in which you're going to connect the input output, okay, such as a LED, or you have a sensors, or you have you're going to convert from analog to digital. Okay, so you're going to do the basic interfacing, okay, by connecting your input output, and then you connect it to your processor, and then after that you're going to do the programming and see whether the programming is work or not. Okay, so this is the learning outcome. Okay, so you at the end of this study here, you will able to describe and differentiate all the components of microprocessor-based system. Okay, so you can know how many ports that are available in Atmega 32, what are port that used for the analog to digital converters. Okay, so how to initialize the input output port, how to do the timer, how to set up the interrupt programming, and all those things. Okay, so and then the second one here, you're going to analyze and design AVR Atmega 32 based on the assembly language, as I mentioned earlier. Okay, so this project, where this course here is focused more on the programming part. Okay, so make sure that you ready. Okay, make sure that you equip yourself. Okay, to learn how to do a programming. Okay, we have two language that you're going to learn here. One is the assembly language, and the other one is C programming. Okay, and the third one here, we're going to analyze and design our AVR Atmega 32 microprocessor system. Okay, by using the Atmega 32 chips. Okay, you're going to do some analysis, and then after that, you're going to design based on the certain problem. Okay, and last but not least, work with AVR Studio and communicate effectively in a team to solve complex AVR Atmega 32 design problems. So this is the what we call here. Okay, so this is the last learning outcome that you going to know after you finish this course. So what in this course? Okay, so actually in this course you're going to learn about assembly language programming as well as a C programming, and then you're going to learn about the microprocessor concept. So how the microprocessor works, how the what we call here, how the architecture of that microprocessors, and last but not least is the hardware interfacing. Okay, how you going to connect, or how to you're going to wiring the input and output to the microprocessors. Okay, so this course here, okay, there is a prerequisite in order to take this course. So I assume that all of you already took SKEE 1223, which is the digital electronics. Okay, so why? Because in this course here, okay, you will use the number representation, which is we frequently regularly use the how to convert from binary number to hexadecimal number. Okay, and then logic circuit. Okay, the realization of simple logic circuit. So in this course also you will learn about the exclusive OR, exclusive NOR, AND gates, NOT gate, NOR gate, all those things. Okay, and then integrated circuit logic and all these things. So make sure that you need to recall back all of this your previous SKE 1223 courses. Okay, so this is a course policy. The attendance is compulsory, of course lah. Okay, if the attendance is less than 80%, so you're not allowed to take the final exams. Okay, you are responsible for whatever is taught in the lecture. If you miss a class, it is your responsibility to find out the assignment, quizzes, and exam from my website here. Okay, all of the information regarding the quizzes, assignments, tests, and final exam will be posted in this website. Okay, and punctuality is expected. Okay, so because this is an online class, or of course, all of you will be punctual. All right, so I assume that all of you will be punctual. Okay, you are encouraged to collaborate, not to copy on assignments, problem with your study buddies. Okay, regarding the assessment, okay, so this is the distribution of the assessment. Okay, we have a group assignment and presentation, as well as the quizzes. Okay, so it will contribute to 20% of the marks. Okay, then we have a 2 tests. Okay, test 1, okay, will be scheduled on 28 April. Okay, so please block the date here. Okay, maybe we will do it at night. Okay, and test 2 on 9 June. Okay, so we have 2 tests. Test 1 on 28 April and test 2 on 9 June. Okay, so this will contribute of 30% of your theory marks. And last but not least is a final exam. So this is a 50% of the marks. Okay, so regarding the references, okay, so I will use this book here. Okay, so the AVR microcontroller and embedded system, using assembly and C by Muhammad Ali Madiri. Okay, so you need to find out this book here, okay, for further references. Okay, and then last but not least, okay, we are going to use the Atmel Studio 6, okay, in order to do the what we call here, the group assignment, as well as we are going to use the Proteus software in order to do the group assignment as well. Okay, before we start our class here, let's look at this course information outcome. Okay, so for those who just joined in, okay, please scan the QR code here for today's attendance. Okay, I will give you around 2 or 3 minutes, okay, to scan this QR code for those who just joined in the class. Okay, so let's look at this course information. Okay, so this is a course information for this subject, okay, which is SKE 3223. Okay, so as I mentioned earlier, all right, so we have a 4 course learning outcome. Okay, so this is a CL11 until CLO4. Okay, in which for the CL1, okay, you're going to describe and differentiate all the component of microprocessor-based system. Okay, so and then for the CLO2, you're going to analyze embedded solution based on the microprocessor system, and CLO3 is use assembly language. Okay, so you're going to use the assembly language as well as the C language and HLL design tools to analyze and design microprocessor-based embedded system. And last but not least is to design a complex microprocessor-based system that meet design specification. So in this course here, you have 4 course learning outcomes that are what we call here mapping to 4 PLO. Okay, so CLO1 will be mapping to PLO1, CLO2 for PL3, and this. Okay, so this course learning outcome will be uploaded in the learning by today. All right, so this is the weekly schedule. Okay, so we will have 15 weeks here. Kita akan ada 15 minggu. Okay, so let's look at the week 1. Okay, so this week here, okay, we're going to learn about the module 1, which is an introduction to embedded system. Okay, so in this introduction to embedded system, you will learn about the embedded system, and then you will learn about micro P and micro C. Okay, so what are the different between micro P and micro C? And then you also will learn about the major component of the micro P and micro C, which is consists of processor, memory, and I/O, and then all these things here. Okay, so this must be done in a week 1. Okay, for the week 2, okay, if you can see from this course information, okay, so every week we need to finish 1 module. Okay, so we have a total of 30 modules, so we need to finish 1 week 1 module. Okay, so for week 2, so this is a module 2. So the module 2, which is introduction to AVR architecture. So in this module here, you will learn about AVR architecture. Okay, the ATmega 32 chip that we're going to use in this course here. Okay, and then after that, module 3, embedded system programming. So we'll start the program by using the assembly language. Okay, so in this embedded system programming, you're going to learn about the addressing mode. Okay, we have a few types of addressing mode, how to what we call here, to get or to move the data, okay, by using addressing mode. So we have plenty of addressing mode to use from. Okay, then we're going to learn about the register set, how many registers that are available in ATmega 32. Okay, what are the ALU machine instruction format, and introduction to AVR Studio. Okay, so in the week 4, so this is an assembly language programming. So in this, actually in week 3 and week 4, you will start doing the programming by using the assembly language. Okay, module 5, okay, you will learn about how to write assembly programming for the arithmetic, logic, and bit operation, shift instruction, and shift instruction. Okay, so we have a lot of instruction that you're going to learn in this part here. Okay, so you're going to do for the arithmetic, you're going to use the ADD instruction, SUB instruction, then we have the multiply instruction and all those things. And then this is for the arithmetic parts, okay, which is you're going to do the addition, subtraction, multiplication, and division. For the logical part, there are instruction called as OR, AND, exclusive OR, and etc. Okay, so this is for the logical, and then bit operation, shift instruction. Okay, and then the module 6, so this is masih lagi, okay, so this is still in assembly language. Okay, you will learn about the shift and rotate instruction. So this instruction also will have a few instructions that you're going to learn, such as ROL, ROR, okay, ASR, and etc. Okay, and then we have for the module 7, so this is a program control instruction. So in this module 7 here, you will learn about the what we call here, how to do a loops by using the jump, branch instruction, skip, and compare instruction. Okay, and then for module 8, okay, you will learn about stack and subroutine. Okay, so here you will learn about the stack pointer, how to initialize the stack pointer, how to put the data into the stack pointer, and how to read the data from stack pointer. And then module 9, so we will start with the C programming. Okay, so on module 9 onwards, you will learn, you will start with C programming. Okay, so from module 3 to module 8, so that one is the assembly language. And then after that, module 9 to module 13, that one is for the C programming. Okay, okay, so as I mentioned here, okay, we will have two tests. Okay, so test 1 will be held on, okay, there is the schedule of the test 1 is 28 April, as I mentioned earlier. And then module 9, 10, 11, 12. So this is a C programming. Okay, so first you will learn about the introduction to C program. Okay, how to initialize the data type. Okay, what are the logical and arithmetic operation, and the symbol to do that logical and arithmetic operation by using the C programming or the syntax of C programming. Okay, and then after that, Atmega 32 GPIO. Okay, so now you will learn about how to do the interfacing between the input and output. Okay, so we have a few inputs such as a LED, switches. Okay, and then after that you have an output and such as what we call here lamp, or you have the output 7 display and all those things. Okay, how to do that interfacing and connected to the Atmega 32. And module 11, okay, so this one here you will learn about the timer programming. Okay, so in this class here, okay, you will learn about 3 timers. Okay, timer 0, timer 1, and timer 2, and how to write this timer in order to create a certain delay. Okay, and then after that, okay, you will learn about the interrupt programming. Okay, we have a few interrupt. Okay, one we call it as external interrupt, the other one call it as a timer interrupt. And last but not least is how to do the analog to digital converter. Okay, how to program ADC. Okay. So this is the quick overview lah for SKEE 3223 microprocessor process. Okay, so this course learning outcome I will upload in the e-learning by today. Okay, so up until here, any question? Ada soalan tak sampai sini?
Dr. Askio,
Yeah.
for the quiz assignment, you will not send at the e-learning, right, Dr.?
Okay, for the quiz assignment, okay, the quiz I will not send in the e-learning, but for the assignment, okay, you need to upload all the assignments in the e-learning. Okay, I will give a link. Okay, every time you have a quiz or assignment, I will give the link. Okay, and I will update to you.
Okay, Dr.
Okay, boleh ya, Mirul? Okay, so and then, okay, as I mentioned earlier, okay, so all of the what we call here announcement will be updated in this website. Okay, you can go to my website afzan.fke.utm.my. Okay, so you will click to this announcement. Okay, all of the announcement regarding the group assignment, okay, and the test and quiz will be posted here. Okay, in this website. Okay, and in the meantime, okay, so all of the what we call here online class also will be uploaded to the YouTube. Okay, you can go to the YouTube and search Afzan SKE. Okay, and then do subscribe my channel. Okay. So inside of this what you call here channel, okay, you will see the previous classes or the previous online class, okay, for microprocessor class, as well as I will upload our class to this channel as well. Okay, so that is for the introduction part. So any question? Any other question? Ada soalan lain tak?
No, thank you.
Okay, if no question, so now we start with module 1 because we need to finish our module 1, okay, this week. Okay, we have one module, 1 week. Okay, let's look at the microprocessor-based system. Okay, so this one you already covered in the previous slides. Okay, so we just skip this part here. And now we're going to see what is computer. Okay, so a computer is actually a electronic device, okay, for storing and processing a data, typically in a binary form according to the instruction given to it in a variable program. Okay, so actually the computer use, okay, to store the data and to do data processing. Okay, usually the data that will be stored to our computer are in the binary form. Okay, sometimes, okay, it will store in hexadecimal number, but most of the time it will be stored in binary number. Okay, there are 4 basic functions of computer that you're going to know. Okay, for the first one here, we call it as a data processing. Okay, so in this data processing here, you're going to process a data. Okay, which is you're going to do the arithmetic logic, arithmetic function. You're going to do the logical function. Okay, so for the arithmetic function, you have operations such as addition, subtraction, multiplication, and division. These are how you're going to do the data processing by using the ALU, okay, arithmetic logic units. Okay, and then a part of that, okay, the computer also used to do the to make it as a data storage. Okay, a part of you do the data processing, you can also store data inside of your computer. Okay, so this data will be stored in the, okay, there are 2 types of what we call here data storage. Okay, one is a volatile data, volatile storage, and the other one is non-volatile storage. Okay, so next, the third one here is to do a data movement. Okay, the data movement means that you're going to move a data from one location to other location. So that is the data movement, and the last function of computer is to control. Okay, how you going to control the data? Is it you're going to read a data or you're going to write a data? This is how the computer going to control the data. Okay, so if you can see here, okay, the control mechanism is at the center of these functions here. Okay, by using the control mechanism, it will control either you're going to do the data movement or either you're going to store data to your storage, or either you're going to do the data processing. Okay, so this is a control mechanism, is the main part, the main function lah. Okay, and then it will control how to do the other 3 basic functions. Okay, and then so let's look at the computer system. Okay, whenever the word microprocessor is mentioned, okay, most of us think of this computer such as a PC or laptop. Okay, most of the time, every time you heard about the microprocessor, and you will think about your desktop and your laptop. Okay, so now maybe at the most is your smartphone lah, because now smartphone is another device, okay, that we frankly use, okay, in our life. Okay, so this is what you will think about the microprocessor. Okay, but in this course here, okay, we will look at another type of computing system which is far more common than you ever imagine. Okay, apart of the PC, laptop, and smartphone, we have other type of computing system that you will learn in this course. Okay, so let's look at the computer. Before we go more details on the computer, let's look at the computer classification. Okay, so the classification of the computer can be divided into 5 types. Okay, so the first one is a servers. Okay, so I assume that all of you already know what the server is. Okay, so this server is a big, expensive, and available 24/7. Okay, so server is actually a computer or a computer program that manage access to a centralized resource or service in network. Okay, every time you log into the internet, okay, you go to your web browser and you type the www, so it will connect it to the server. Okay, so that is the server. And then we have the desktop. Okay, so the desktop is a computer on your desk lah. Okay, and we have a laptop. The other type of computer is a laptop, which is a computer that you can carry in your bag. So this laptop here is what we call here one of the most device that currently used. Okay, then we have a PDA, tab, and smartphone, which is we call it as a personal digital assistant. The PDA is a personal digital assistant because before the smartphone and tab is existed, okay, there is a one device called as a PDA, and after that is evolved become a tab and smartphone. Okay, so this one here, PDA, tab, and smartphone is a computer that you can carry in your pocket. And the last computer system, the last computer type called as a embedded system, which is a computer that don't look like a computer. Okay, so actually the embedded system is a type of computer, but it's not looks like a computer. Okay, so what is the embedded system? Okay, so actually the embedded system is a computer system with a dedicated function within a larger mechanical or electrical system. Okay, often with a real-time computing constraint. Okay, so that is a embedded system. Okay, how this embedded system looks like? Can you give example? What are the embedded system that you can think of? Boleh bagi tahu tak? Example of embedded system. Can you tell me?
Is it depends on sensors or something like this, like a microcontroller?
Okay, so embedded system is actually one of the embedded system that I can give. The easy embedded system that I can give you is your calculator. Okay, that is an embedded system. Why? Because in that embedded system you have a microprocessor, and then you have a what we call here. You have the input output. Okay, you have a keypad to key in the value, and you have a LEDs to display the outputs. Okay, and then as well as it have a memory. Okay, so computer must have 3 main things. Okay, which is CPU, your processor, and then you need to have an input output, and the last one here you need to have the what we call here storage, data storage. Okay, that is the
Memory.
3 main idea. Memory, yeah, correct. Okay, the data storage or memory. That is the 3 main things inside of a computer.
Yes.
Okay, so as I mentioned earlier, embedded system is a microprocessor-based system that is built to control a function. Okay, so a function of or a range of function, and it's not designed to be programmed by the end user in the same way that a PC is. So means that the limitation of embedded system is it only can control, okay, it only can do a certain function. Compared to PC, okay, you can do many things in your PC. Okay, you can, and this PC also is a end user programmable. Okay, means that you have a PC. Okay, if you're going to watch a movie, okay, then you need to install what you call here the okay. In order to watch a movie, you need to install what we call here the what program that you usually use to watch a movie. Is it a AVI player?
AVI player.
Okay, one of this the thing is the AVI player. Okay,
Yes, okay, yes.
if you're going to what we call here to listen to a song, so you need to have an MP3 player.
Yes, okay, yes.
Okay, and then if you're
MP3,
going to connect to internet, then you need to install your web browser. So after that, after you install the web browser, then you can connect to internet.
internet.
Okay, so that is a PC. Okay, which is it is a end user programmable. Okay, you can program the the function that you're going to use, okay, in the PC. Okay, compared to the embedded system, it only have a limited function. For example, your calculator. Okay, for the calculator, you can do the calculation process only. You cannot listening to the music. Is it correct? You cannot do the what we call get the temperature. Okay, so because it has a limited function. Okay, compared to the PC. Okay, so that is the difference between the embedded system and the PC. Okay, so can you give an example of embedded system? Okay, you can go to the slido.com and key in this code here, or scan this QR code, and I'm I'm going to see what are the example of other embedded system that you have in mind. Okay, I give you around 5 minutes to do that. Okay. Right. Okay, we have one response here. Okay, we have 80 students, so I assume that we need to have a 80 response lah. Okay, 5 already respond. Okay, keep going, guys. Okay, so this is an example lah, embedded system that you listed here, such as a DVD player. Yes, DVD player is one of the embedded system, and then you have the GPS system to do the tracking. Okay, and you have a digital camera. Okay, to take photos and do processing. Okay, water heater, and then we have a smartwatch also as one of the embedded system. Okay, in the smartwatch you can take. Okay, you can do a certain function such as take the instead of give you a time. Okay, you can also can read the ECG signals from your smartwatch. Okay, it also can can do a data logging. Okay, the distance you take to travel from one point to another point. Okay, then we have a water heater, TV, okay, electronic calculators, MP3 player, washing machine, okay, GPS system, audio system, and television. Okay, so these are embedded system. Okay, which is it will do a certain function. Okay, the function is very limited to do a certain function. Okay, you cannot add another features to that embedded system. Okay, okay, I see the PLC here. Okay, actually PLC is not embedded system. Okay, PLC is your processor. Okay, it's not embedded system. Okay, now we go to next slide. Okay, so this is an example of an embedded system. Okay, inside of your car, you have a lot of embedded system actually. Okay, so let's look at this for the driver assistant. Okay, so for the driver assistant, we have a lot of embedded systems there. Okay, one of the embedded system for the driver assistant is such as an adaptive headlight. Okay, in which that the headlight will auto turn on and turn off, or okay, according to the incoming cars. Okay, then you have a night vision. Okay, and then self parking. Okay, so this is the new technologies here. Okay, in which you can do the self parking. Okay, blind spot detection. Okay, you can see in the side mirror, you can see the blind spot detection by looking at the LEDs. Okay, the LEDs lamp on the side mirror. Okay, for the security, okay, you have a remote keyless entry. Okay, so that one is one of the embedded system. Okay, immobilizers, and for the what we call here, and then we have the okay for the instrumentation. Okay, you have the instrumentation cluster, head-up display. Okay, to control your infotainment units. Okay, you can play the MP3s. Okay, you can watch a movie and control your aircon climate. Okay, you can do that. Okay, so there is a lot of embedded system inside of one cars actually. Okay, so I just want to inform you. Okay, a smartphone nowadays is not an embedded computer. Okay, a long time ago, a handphone is an embedded system. But now, because the smartphone is very is a end user programmable, so it cannot we cannot group it as an embedded system anymore. Okay, the smartphone is now called as a computer. Okay, why? Because this smartphone here has a complete system that similar to the PCs, similar to the computer. Also, okay, it have the end user programmable. Okay, so that's why we cannot class the smartphone as a computer. A few years back, yes, you can class your handphone as an embedded. Now you cannot do that. Okay, so now let's look at the general purpose computing versus embedded system. Okay, so general purpose computer is the computer lah. And then what are the difference between the computer and embedded system? Okay, one of the difference here is for the computer, okay, it's intended to run a fully generated set of applications. Okay, so you can run a lot of applications in your computer. But for the embedded system, it can only run a few applications, often known at a design time. Okay, so for the embedded system, you cannot add another features, okay, in order to do a new application. Okay, so that is the difference between general purpose computer and embedded system. And the computer is end user programmable. Okay, if you're going to run a to do another application, so you just install or you just program the application to your computer, and then after that you can run that application. For the embedded system, it is a not end user programmable. Okay, you cannot add a new features or new application to your embedded system. Okay, so this one here, okay, for the computer, the faster is always better. Okay, of course lah. Okay, you need to have a very faster and reliable computer. Compared to embedded system, okay, so embedded system only operate in a fixed runtime constraint. Okay, so additional performance may not be useful or valuable. Why? Because you only going to run a few applications. So your what we call here, your embedded system not required to have a faster processing unit or bigger RAM. Okay, because only a few applications that you're going to do. Okay, so that's why it operates in a fixed runtime constraint. Okay, other different. Okay, so the way we're going to differentiate the features for the computer here is the speed of the computer, of course lah. Okay, and then the software compatibility. Okay, and the cost. Okay, so the cost is the main factor in differentiating the features of the computer. Okay. In terms of the speed, okay, so you have a two laptop. One laptop is run on what we call here 4 gigahertz, and the other one run in 1 megahertz. Of course, the 4 gigahertz must faster. Okay, and then this laptop A have a SSD, and the laptop B is only hard disk. Okay, standard hard disk. So SSD is much faster compared to standard hard disk. Okay, so this is how you're going to differentiate between one computer to another computer. What about the embedded system? To differentiate between one embedded system to another embedded system, we're going to see at the power usage. Okay, maybe this calculator use a 1.5 volt battery. Okay, but the second calculator use a 5 volt battery. So this is how we're going to differentiate. Okay, of course lah, a cost. Okay, the cost of calculator A compared to calculator B, and the size. Okay, so this calculator is smaller in size, but this calculator B is bigger in size. Okay, and speed, this is not necessary sangat lah. Okay, must be predictable. Okay, so this is not necessary because the embedded system only run a few applications. Okay, so to design microprocessor system, okay, so you must know this thing here. Okay, first the fundamental, what is inside a computer and what is inside a processor, and then the second one here, how to do a programming. Okay, so what happens if the processor when it's running a program, and what do we need to write a program? So you need to learn about the instruction and syntax of that program. how to create a program, how to run a program, and how to fix a program error, in which you're going to do the debugging process. So this is under the programming part. And for the hardware design, so this is for the timing diagram and interfacing with other chip. Okay, how you're going to interface with your input output, and how you're going to interface with other chip, okay, or other IC. So I think I will stop here for today. So tomorrow we'll continue with module 1. Any question up until here? Ada soalan tak?